Alright, since I know everyone here is ready to go, we are doing our best to pretend like we really want to be here and we're excited to be here, right?
Yeah.
So, yes, we're gonna really work on that. So, alright, so class.
Yes.
Hey, not bad. Alright. So, kinematics number 3. So we have velocity squared is equal to my initial velocity squared plus 2 times acceleration times my change in x, which is also referred to as displacement, or my delta x. Now, you people, right now, you're going to write down what information we have. You're driving through a town at 12 meters per second. When suddenly a ball rolls out in front of your car, you apply the brakes and begin decelerating at 3.5 meters per second squared. How far do you travel before coming to a complete stop? What information is being given to me here? Go ahead, throw stuff out. Acceleration. My acceleration is
3.5.
anything else?
Velocity.
My velocity. Is it my end velocity or my initial velocity? My initial velocity. (12 meters per second). Anything else? What is my ending velocity?
0.
Why is it 0? And then you are go to a stop, right? Anything else? That's it. That's all we need. So we go through and identify everything that we need and everything that we have. So on this one right here, the formula is already on the board. The formula is there. So my ending velocity right here, my ending velocity, my initial velocity, my acceleration, and my change in x, my delta x, my change in x. So that's what it's looking for this time. So what do I want? I want the change in x, which is my delta x. Yes. Hopefully. So we can go through and start plugging these in. What was the ending? Ending was my initial velocity 12,
12.
and plus 2 times acceleration times my delta x. Now, there's one problem with this problem. One problem with this problem. My acceleration. What's wrong with it? It's not negative. Why should it be negative? I'm decelerating. I'm coming to a stop, so I'm slowing down. So I have a positive velocity, and something comes out in front of my car, I need to decelerate. I need to slow down. So I'm going to have a negative acceleration there. There we go. Now, for you people, so I know calculators are always a good thing. So if you are one of those people that need a calculator, please go ahead and grab one. All right, variable is over here. So we need to solve for that variable, right? So on this one here, the variable is not by itself. So I need to solve for that. So what I'm going to do is, I'm going to start doing the math. So it's 0 equals 144 minus, because 2 times 3.5 is a negative 7, delta x. I need to get my delta x by itself. So this piece right here needs to be isolated. So to undo this, I need to start by getting rid of my 144. How would I do that? Very good, very good. So I'm going to subtract 144. Negative 144 is equal to negative 7 times my delta x. And to get my delta x by itself, I have to undo that negative 7. So I'm going to divide both sides by negative 7. You're almost sounding enthused about this. I'm going to pick on Anthony here on this one. Because I know you got it. You plug in the calculator yet? That's what I'm hoping for. So those people that are not currently being called on, I highly recommend actually plugging it into the calculator because quite randomly, you will get called on too. 20.57 what? Go back to the problem. Think about the problem. What did it say? It's going to be meters, but from the problem, it was saying I was looking how far you travel before coming to a complete stop, right? So when you think about it like that, you need to read through the problem and see if it makes sense. So 27 meters, yeah. Or I'm sorry, 20 meters, yeah. Good job. There's a good chance that a guy named Roberto might be called on the next one. Just because. I'll just throw it out there. Just randomness out there. Common problem students have, I don't know which equations to use. Now, these x's right here, what do those x's mean? They're not variables. What do those x's mean? Mean what? So right here, it says velocity of x and initial velocity of x. My acceleration of x. What direction are we going? All these are going in which direction? Right and left. Because it is horizontal. It is along the x-axis. So this is going left and right. That's what this is actually meaning. If it was going up and down, what would that have on it? It'd be the velocity of if it's up and down, what would it be? Why? Because I asked you. See what I did there? See what I did? And it'd be initial velocity of I keep asking the same thing, yeah. And it is the acceleration of. So this is telling me the direction it is going. It is in the horizontal, so it's going to be left and right. This one right here says missing variable v. So let's see. I have this, which is technically a change in x. My x initial, my velocity of x initial times time plus 1/2 acceleration of x times time squared. So there's some variables that we don't actually use and we don't need all the time. So this one right here. So it's the velocity of x squared is equal to the initial velocity of x squared plus 2 times acceleration of x times, this one right here is my delta x, my change in x. This one has no t in there. All right, all three kinematics can be used to analyze one-dimensional motion in either horizontal or the vertical direction. It's almost like I just got done saying that. So in a vertical direction, Julia, in the vertical direction, can you explain to me what equation it would look like? What would my equation look like if it was in the vertical direction instead? Initial. Is that so bad? No, it just means we're going in the other direction. Means we're going to be going up and down. Quite often, you're going to see a lot of these in up and down. And help me with this next one. What's this next one going to look like? Show why. Initial y, very good. Okay. Not so bad. Just means that we're up and down. This last one right here. Let's go Luis. There we go. That's it. Not so bad, right? G, or A of G, acceleration due to gravity. Acceleration due to gravity is constant that exists in a vacuum, meaning that without air resistant, if an object is in free fall, gravity will change its object velocity by 9.8 meters per second per second. So that means my acceleration is going to be going down 9.8 meters per second squared. So in this example, this is going to be what it is because of my acceleration. So at 0 seconds, what is my speed at 0 seconds? What is my velocity at 0 seconds? 0, right? Because it's in my hand. And okay, so after 1 second, it's increasing. So what they're doing here is they're estimating and just calling it 10 meters per second squared. So you could do this on a lot of the AP exam if it is a free response type of question. If it is a question with a calculator option that you're allowed to use your calculator, that's where you're going to use your 9.8. So we're estimating. So at 1 second, it is 10 meters per second. 2 seconds, because it's accelerating at 10 meters per second. Every second, it's increasing by 10. So at 2 seconds, I'm up to 20 meters per second. 3 seconds, 30 meters per second. 4 seconds, 40 meters per second. 5 seconds, 50 meters per second. So as we keep going down, it's going to keep increasing by 10 meters per second. And that is my velocity is changing. Does that make sense? Now, is there a point that it's actually going to stop increasing? Yes, there is. Roberto, what is that called if it stops increasing? It's not in the notes. That's what I'm asking. Splat? No. So something falling and it stops increasing, but it's still falling. It's called the terminal velocity. There's a point in which that gravity is not going to pull on it any more than what it currently than it is. So you have a terminal velocity. So there's a speed that everything will eventually get to, and that will be it. I'll use this as an example. So let's say, for instance, you live in the city on 4th of July. Okay. What happens on 4th of July? Okay, anything else besides fireworks get shot off? Yeah, there's people that shoot guns up in the air. Now, if you think about it, what happens? Those guns shoot up in the air and they come back down. Okay, so do we hear in the news all kinds of people getting shot by bullets coming down? No. Why is that? Huh? No. There is a law, but not the same one. We're talking Isaac Newton versus, Maricopa County. All right, keep that same thought. Now, how about this? Every day, people drop pennies off the Empire State Building. Do we hear about people getting killed walking by the Empire State Building in New York? No. Why? Gravity. Gravity, when people throw that penny off, it's going to just keep flying. Is it going to keep picking up speed the whole time? It's not. That's where we get that terminal velocity, where it gets to a point. So that goes back to, as you throw it off, it only can go so fast. And since pennies don't really have any mass, if they hit you, you're not getting injured by it. It's not really scratching your car or breaking your windshield or anything like that. Same thing goes with the bullets that were being shot up in the air. As they come back down, they have a small mass, and as they come down, they only go as fast as gravity says to, because they go all the way up, they lose their momentum, and they just come back down on the speed of gravity. So that's why people are not getting, killed by those. Anyway, just a bunch of randomness for you. Stone is dropped at rest from the top of a cliff. It is observed to hit the ground 5.7 seconds later. How high is the cliff? How high is the cliff? What do we know? Brandon. You know the time? Okay. Anything else? You have to get this from actually reading through it by understanding what the problem is saying. All right, starting here, right? What am I going to do? So what do I know if it's starting here? Initial time? Not really. I don't need initial time. Well, I'm starting here. Is it moving? So what do I know if it's not moving when I'm starting? Anyone want to help him out?
Zero acceleration.
Zero acceleration. Anything else? That's my initial acceleration. But how about my initial velocity? Initial velocity. So it's starting from 0, right? It's not moving. It's starting from 0. Roberto. Anything else you know from right here, from this information?
Gravity?
Gravity? What's gravity?
9.8 something.
Okay. There's one more thing that I know. Where are we starting at? Okay, so that would mean my initial is at 0 meters. I'm starting from from like sitting here in my hand. I'm not throwing it. So my initial y value is 0. So when I let go of it, bam. My initial velocity, 0 meters per second. My initial position is 0 meters. My acceleration is negative 9.8 meters per second squared. Okay. So my formula. So I have, let's see, I have 3 formulas here. All right, this one here, what am I looking for? How high is the cliff? So if I'm dropping something off the cliff, I'm looking for the what? The y final or my change, right? So yeah, it'd be my my delta y. So it's the change in y there. So I'm going to have y equals my initial y was 0 plus my velocity initial was 0 times 5.78 plus 1/2 acceleration negative 9.8 times time 5.78 squared. All right, let's see. So 0. 0 times 5.78 is going to give me anything times 0 is 0. Good. Those all go away. So I'm left with I don't know, whatever. What'd you guys come up with? 160 what? Point 0. What are my units? Just meters, because this is the height of a cliff, isn't it? Next one. How long does it take a car at rest to cross 35-meter intersection after the light turns green if the acceleration of the car is constant 2 meters per second squared? Start listing what we know. Somebody start with what we know. What do we know here? A, right? 2 meters second squared. Anything else? X final, right? My delta X is 35 meters. Do you know what X initial is? Why is X initial 0? Starting at rest. Okay, if I'm starting at rest, what is my velocity? So that's going to be my initial velocity. Anything else? What am I looking for? I'm looking for time, right? Good. I'm looking for time. So given this much information right here, I have my X position where I want the end, I got initial, I have velocity. So that's going to end up being this formula right here. So my change in X, my displacement here is I want 35 meters. My initial X is 0 meters. My initial velocity is 0 times my time, which I'm looking for, plus 1/2 acceleration, which is 2, and time squared. Anything times 0 is 0. Anything times 0 is 0. So that's going to help me out here. 0 is my favorite number because it gets rid of this and that t right there. So I should have 35 is equal to 1/2 times 2 t squared. 1/2 times 2. What happens there? They cancel out. I get 1. So now I get 35 t squared. Now, how do I undo a square? Square root. So when I do the square root, do not forget this. So I'm going to get t is equal to the plus or minus square root of 35. You cannot forget that plus or minus because especially in problems that we're dealing with like x values, my positive could be going to the right, the negative could be going to the left. But on this one right here, can I throw away one of those answers? Anthony, which one am I throwing away? The what? It's a positive or a negative. Which one of those can I throw away? Negative, yes. Why can I throw away a negative? Can you have negative time? There you go, right there. So when I'm doing this, though, you have to account for everything. You cannot have a negative time. So I could disregard that answer. So I'm going to say that my time, if you plug it into the calculator, it's, I don't know, 59592, 591, 591. So that would be 591 seconds. Yes, no, maybe. So we're picking this one up tomorrow. Make sure you all like, share, and subscribe. Hit that notification button. And my recording did not work out first hour, so it has to be this hour. Use the rest of this time too, please. You can work on your assignment or work on the assignment that you owe me. Non-plan.